Hi guys, welcome back. I hope I'm visible to you guys. Let me just check real quick. Let me just go to my. Hi guys, welcome back. I hope I'm visible to you guys. Let me just check. Okay, real quick. All right. Let me just. All right. Let's get started. So welcome to the class. My name is Madhu Kashyap. I'm a physics educator at an academy. I'm an astrophysicist from Bengaluru. I'm a young scientist awarded from Indian Science Congress and young researcher awarded from European Space Agency Netherlands, and also an author of a book. For more details, you can Google me or Amazon me or Flipkart me, whatever. Okay, right. Let's get started. Guys, welcome back. So welcome to the class. And my name is Madhu Kashyap. I'm a physics educator at an academy. I'm an astrophysicist from Bengaluru. I'm a young scientist awarded from Indian Science Congress and young researcher awarded from European Space Agency Netherlands, and also an author of a book. For more details, you can Google me or nice to see you back. Okay. Hi guys, welcome back. Hi. And okay, today let's get started, guys. We're gonna continue the topic for IOQA and NSEA concepts. Okay. Good. Hi. Guys, in the last class, I think I started with introducing you to the celestial coordinates, right? So today we are going to dive deep into those celestial coordinates with the pictorial representations and all these things in detail. Let me quickly put my pen tab intact, and let's get started. Okay. Okay. What if we were a simulation? Wait, we will discuss such kind of. I think such kind of discussions will take place in some other place. All right. Okay. So we were talking about to begin with, we started our understanding from spherical coordinate system. Okay, so let's look at the spherical coordinate system with respect to astronomical point of view in detail. So let me just write this spherical coordinate system. Okay, so we look at this in detail. Okay, so imagine if I can just draw a sphere. Is there a way I can make shapes here? Okay, anyway, let me draw this, no issues. So let me draw a circle, sphere. Arey yaar, my sphere looks very bad, don't worry about it. So let us put a central pole here. Okay, so this is a pole P and P dash. Okay, and we have, let us put this as the central part, and we will draw a small circle. Okay, this is a small circle, and we are gonna draw one more from the center, which will be like a longest chord. This we can call this as a small circle. Okay, and this we will call it as great circle. Small circle and great circle. So short, we can call the shortest distance. So if there are 2 points, let us say Q and Q dash, so the shortest distance would be these 2 points. So that's how. And here P and P dash are poles here. P and P dash or poles here. Okay, so what are we doing here is, if a plane passes through the center of the sphere, it will basically split circles into two identical hemispheres, okay, along a circle called great circle. So identical bifurcation is seen through great circle. And yeah, kind of you can talk with respect to geodesic if you are talking with the shortest distance between any 2 points on a curved surface. So this is how a great circle looks like. And when we are talking about small circle, it is basically a perpendicular line which is passing through the center of the sphere and intersects the sphere at P and P dash. Okay, so that's what a small circle looks like. So this is the terminologies we use, small circle and great circle, in describing certain celestial coordinate systems. Okay, so that's how we begin our understanding towards the systems. Okay, different systems which we discussed in the last class as well. Let me just quickly add some slides. Okay, quickly. All right, just putting into a screen mode here. Yeah, similar to last one, but I'm gonna draw with pictorial representation. So we started with terrestrial coordinate system, right? We spoke about terrestrial coordinate, horizontal system, equatorial system, galactic system, elliptic system, Mediterranean system, all these things, right? So we are gonna look at those diagrams with respect to great circle and all this, the range of latitudes and longitudes we are looking at. Okay, so we will start with terrestrial systems, terrestrial system to begin with. Okay, so let me quickly draw the circle again. Okay, imagine this has north and south poles. So this is north pole and this is south pole. Okay, and now we am gonna draw a central circle here. Okay, so let me draw one more arc here from north pole to south pole. Okay, and let me mark a point here P. Okay, and this is towards the center. Let me draw this. Okay, towards the center, this is the point we are talking about. And from here, the one which is touching, we can call this angle as L, small l. And from here, this point P, this angle, we can call it as phi. So this L, phi comma L, okay, is basically latitude and longitude. This is latitude and this is longitude. And the range, if I have to talk, it will be from 0 degree with respect to L and 360 degrees. Okay, and when we talk about longitude, it will be minus 90 degree to plus 90 degree. Okay, this is with the terrestrial coordinate system. Then we head towards the next part, which is azimuth system or horizontal system. Okay, azimuth or horizontal system. Let me quickly check the chat. Top chat. Okay, live chat. Okay, all right. That would be a solid angle. Okay, so we don't talk about solid angle as such, we are just talking with respect to the celestial coordinate systems right now. Okay, so the next system is basically horizontal system, horizontal system. When we talk about horizontal system, let me quickly draw this. So here we are going to introduce some new terminologies for you guys. So here, the wherever I said, right, whenever you look up, that will be your point called as zenith. Let us imagine the observer is here. Okay, and this will be the zenith point. This will be the zenith point. And yeah, the opposite part of zenith, we call it as nadir point. Okay, if this is zenith, this is called, the opposite point will be called as nadir point. Let me just draw a quick arc. Okay, and here if you say this is the observer and this is the northern hemisphere, and you draw one more small circle here. Sorry, my diagrams doesn't look good. And let me draw this completely. So this part will be basically the southern hemisphere. Okay, and you can call this as great circle, and second circle, you can call this as first second circle, and here you can call this as the FGC, great circle. Okay, so there will be a point here, there will be a point which from here, this is a point P. You remember this? Where? Okay, so and this point will be the north pole and this point will be the south pole. Okay, this is zenith, this is nadir, and this is the point P, and the angle which is being where these two things are bisecting this point, we can call it as uh, so this is basically the celestial sphere. So we can call this point another point here as S dash. Okay, so here, yeah, these things are done. So we are gonna mark two things. One is called A. Okay, so there is a point called as A, which we call it as azimuth. So you don't have to require west to east or so on and so forth. We talk with respect to Z. So OP and ON is basically the azimuth angle A. So this is called as azimuth angle. Okay, then when we talk about altitude angle alpha, so OP and OS dash, which we call it as alpha, is basically the altitude angle. So this is azimuth angle A and altitude alpha. That great and small circle is based on the frame of reference. So great and yes, basically with respect to the observer. Yeah, we define those things with respect to the okay. So this is how we understand A comma alpha. Okay, azimuth and altitude with respect to horizontal system. Oh, I need to give you the range. So the range this operates, so the range of operation, so it will be 0 less or equal to alpha less or equal to 90, and this is 0 plus or equal to A 2 pi. Okay, this is how the range works. Where are they used? That's a nice question. Horizontal system, basically azimuth and altitude angle is one of the old systems which we use as a two-dimensional coordinate system. Okay, azimuth. So these coordinates are basically with respect to locally convenient. These are just for locally convenience, but not globally convenient. Okay, this can be used for local coordinates. So because alpha and A are place and time dependent. Both alpha and A are time dependent, which we use as a two-dimensional coordinate system. Okay, India. So these coordinates are basically with respect to locally convenient. So these are just for locally convenient. It's locally, but not globally. Local coordinate system, just like this can be used for local coordinates. They were because alpha and A are place and time dependent. Initially, to know the star position, like A, looking at the zenith nadir and looking at the azimuth altitude angles, you will be able to understand where or any other part of the world. Then comes equatorial coordinate system, which is the just like latitude and longitude, they are locally used system. They were used widely in astronomy. Initially, to know the star positioning, like widely used. Looking at the zenith nadir and looking at the azimuth altitude angles, you will be able to understand many things. Okay, then comes equatorial coordinate system, which is the important coordinate system, which is used widely in astronomy. And okay, this is the coordinate system. This is where celestial coordinates. Or if you will say, if you are looking, if you are an astronomer and if you are looking to globally position an object, we use RA and DEC to identify the position of a star or a cluster or a galaxy, any object in space. We usually use this coordinate system. This is where the celestial coordinates. Or if you will say, if you are looking, if you are an astronomer and if you are looking to globally position an object, we use RA and DEC. To identify the position of a star or a cluster or a galaxy, any object in space. We usually use this coordinate systems. You can draw the celestial equator too. No problem. So let me quickly draw this. This is like a documentary for you. Why is altitude not between OX and ON? Okay. This you can call as celestial south. The altitude is basically with respect to the height. Actually, when we look at the position, if the star is here, so what is the height from the ground? So if this is the ground, if you are observed from ground, from horizon, we usually look at horizon with respect to north pole. We locate this point from there where the star is. So from here to here, what is the altitude is basically with respect to the height. Actually, the when we look at the position, if the star is here, celestial equator. So what is the height from the ground? So if this is the ground, if you are observed from ground, from horizon, we usually look at horizon with respect to North Pole. We locate this point from there where the star is. So from here to here, what is the altitude, height of it? So that's how we measure that altitude. That's a nice question. So this is a celestial equator. There is a point. Okay. So here, let me draw. And there is a position here to complete that circle. Gamma. And let me draw one. Let me draw line here. Dotted line here and here. Okay. Here, this is basically the celestial sphere, which is being basically the Earth sphere is expanded to a celestial sphere. Earth North Pole, South Pole is expanded to celestial North Pole and South Pole. For this system, we use this Aries. Okay, this point gamma, whatever I have written, this is a constant. This is Aries. Okay, this is the point of origin of the equator. Here, this is basically the celestial sphere, which is being basically the Earth sphere is expanded to equator, and it is taken as a circle of reference. Okay, expanded to celestial North Pole and actually this is giving the we use this Aries between the elliptic and the celestial sphere. So elliptic is basically the apparent motion of the sun around the that is the point of origin of the equator. So the Aries is the reference we use. If you ask me what is declination origin on the equator, and it is taken as a circle of reference. Okay, yes. So actually this is giving the intersection between the elliptic and the celestial sphere. So elliptic is basically the apparent motion of the sun around the Earth. That's what we are looking at. So the if you ask me what is declination, is directly like this. Declination delta. This is not comfortable with respect to this. Declination delta will be the declination delta. Let me write that. You can hear neatly. Multiple voices looking like some different alphabet. Two more voices. That might be some disturbance outside. Sorry about that. I'm very bad with writing. Declination delta. So this is basically the angle not comfortable made by the star. Angle. Anyway. So declination delta star. You can hear multiple voices with respect to the equator. Oh, two more voices. That might be some equator. So declination delta. So this is the angle made between the star and the equator. That is made by the star. So what do you mean by right ascension? By the what do you mean by right with respect to the equator ascension, which is RA? If you ask me, it is the angle between. Okay, so this is the angle made between the star and the gamma is called as declination. That is so Aries. What do you mean by Aries right ascension? Nu or gamma? Nu and P, right? Okay, point P. This is called as ascension. Which is two voices are coming. That's actually my daughter crying. I guess the angle between this. Actually, this system works and it will be updated every 50 years. Gamma and they are globally used. Aries. This is very much the system which we use globally. P. Okay. This is not a local coordinate system. This is a global coordinate system. And Aries. Two voices are coming. That's actually my daughter crying. I guess to denote this. Right ascension. Actually, this system works and it will be updated every and the range. And they are globally used. This is very much the system minus we use globally. Okay, less. This is not a local coordinate system. This is a global coordinate system. And Aries is the point of reference which we use to denote this like a right ascension and declination. Okay. Okay. So that's how it works. And the range. So two voices are coming. One voice is so it works between minus 90. Oh, you mean dual voice from my less 90? My mean this RA works between 0 RA to 24 hours. So this is like a clock phase hours. Okay. So that's how it. Anyway. Now is it okay? Two voices are coming. Now the echoing has stopped. Voice is some seconds ahead. Oh, you mean dual voice from my. So that's about observational. That's a wrap on observational astronomy. But I'm gonna continue now with the actual, the spectral classification which we started. Now is it okay? Previous classes. Now the echoing. Two voices are coming from my side or something. I don't know. That's weird. Okay. So that's about observational. That's a wrap on observational astronomy. but I'm gonna continue now with the actual the spectral classification which we started in some of the previous classes. Two voices are coming from my side. Oh, that's weird. That's, oh yeah, this seems to be all right. Anyway, is it okay now? Is it okay fine now? Is it fine now? One voice was 20 seconds ahead. Okay, that's kind of spooky. Okay, maybe I will end this observational part here and then do a celestial classification, the spectral classification in the next class. I think I will keep a wrap here because some voice issue is coming. Okay, maybe we will continue in the next class. So we will continue tomorrow with respect to spectral classification, luminosity classification, and everything in detail. Okay. So see you guys in the next class. Until then, have a nice day. And for those who are new for Unacademy, can find the details in the description of Unacademy. If you want to learn from me at Unacademy, you can find that details in the description. See you guys in the next class tomorrow.